Hello, everybody. Today we're going to pick up where we left off with distributions. Yesterday, I just wanted you to see basically how the data was distributed, whether it was centered close together or if it was skewed to one side or another. Today, we're going to go more into the numbers and the use of the calculator. Now, when we left off yesterday, we were talking about the amount of calories in a burger, and we started with the calculator. And what I would like to do is take a look at exercise 1 that's talking about the advanced calculus grades in Mr. Wheeler's class. Now, I'm going to use the words I used yesterday, so you might want to print out some of the notes or write them yourself. It's probably better when you write them yourself, you remember it more. The first thing I said yesterday is the mean, which is an average, and it's an X with the bar on top. Now, this is a typical symbol. It's on all your calculators. It's used around the world. So it's an average, or it's a typical value for the data distribution. Now, what we mean by a typical value is that it's the center of our data distribution. If our data distribution is normal, it would make what we call a bell curve. And if you notice, this is kind of like the curve I was making yesterday or trying to make. Now, if our work fits into this beautiful bell curve, it's a normal curve. And if it doesn't, if it's skew left, meaning a long tail on the left, or skew right, a long tail on the right, the data is not centered. Now, look at here. Now in green, I wrote z-score, and that's how the data is spread. Now, the z-score means how many standard deviations I am away from the mean. So a standard deviation we talked about, but we didn't define. A standard deviation is one measure of the spread of variability. So how is the data varying? And so we make a standard amount of that variation, and that's our standard deviation. And if we are a standard amount above the mean, one standard above the mean or two standards above the mean, the way we label that is with what we call this z-score. If we're one standard below the mean or two standards below the mean, those would be a -1, -2 z-score. Now, the standard deviation comes from our data. And did we take a sample of the data? Then we are a sample standard deviation. And you must have the word sample to be a sample standard deviation, and you would use that S that I showed you yesterday. And if they just say plain old standard deviation, that means we are the population, and it's that O. So if the problem just says standard deviation and doesn't put any special word on it, it's always going to be the population standard deviation. So we looked at these words yesterday, and now we're going to put them into play. So here again, Mr. Wheeler's Advanced Calculus class quiz. Now, let's also practice the calculator. So let me move this so we could still see everything. Okay, that's the grade of 100. So now what we do is we have to always hit second, the plus sign, which brings us to the memory menu, number 4, and we have to clear our list. Clear your list this way to make sure that everything has been wiped away. And just like yesterday, you have to hit stat, enter, and now we have to put in our data 56, 68, 72, 72, 75, 78, 80, 84, 84, 85, 88, 88, 90, 93, 95, 99, 100, and 100. always, always make sure that one, if it says 18 students, your 19th cell is empty. And then always, like I said yesterday, go back up and double check on your list that you didn't type anything wrong. Believe it or not, one digit being wrong, you will get the wrong answer. And since this is a calculator-based question, your answers will either be right or wrong with no partial credit, because I can't check your calculator. And this would have been true even if we were still in school together. On a test or a quiz, I can't check your calculator. Your work is either right or it's wrong based upon your usage. So now I checked and I made sure my calculator was right. Now, what I'm going to do in order to make sure that we do this together correctly, I'm going to move this down a little bit just so that you can see my notes. Oops, wrong thing. I don't want that. Here we go. So now this is what we're going to do on the calculator. We are going to find the average. Now the average is the sum symbol. And this, just like from chapter 6, means the sum of all the data from the first piece to the last piece. And then if you multiply it by 1 over n, that's the same as dividing it by n. So that would be the same as taking the sum of every piece of data and then dividing by the number of pieces of data. But if we do it on the calculator, we hit stat, calculate, and yesterday I said number 1. I still am saying number 1. And then here you go. Here's your average, 83.72 repeating. And so that would round to 83.72. They didn't tell me how to round, so I'm going to keep it as this for right now. Now, the other things on here that are very, very important is here's the sum of my data. If you were to add these pieces yourself, you would have gotten 1,507. And if you were to divide it by 18, that's where your average came from. Now, this is the sample standard deviation. The data is spread on a sample 12 apart. And the population, the data is spread basically 11.7 apart. 18 pieces of data. Now, here's the next thing that's super important that we're going to need. Here is where they give me my minimum value. Here's my quartile 1, which is 75. My median, the middle number, which is the second quartile. Quartile 3, and then the maximum amount. Now, quartiles. Let's talk about that for a moment. A quartile and a median. A median is at the middle. It's the 50% of the data. That means if you put this data in order, and this data is in order, and there's 18 pieces of data, if I now say, let me go, half of 18 is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's the 9th piece of data. Here's the dead center middle. Halfway between 84 and 85, 84 and a half. So you can, if your data has to be in order, you can just simply take the number of pieces of data, divide it by 2, and you get your 50th percent. You get your half. Now, quarters would be a quartile. That's when you split your data into 4. So if there's 9 pieces of data here, half of 9 is 4 and a half. 1, 2, 3, 4, halfway into 75. Count 1, 2, 3, 4, and halfway. So here, this is my first quartile, and 1, 2, 3, 4 and a half. 1, 2, 3, 4 and a half. This is my third quartile. Now, this first quartile here is the 25th percentile. The 25th percentile, so this quartile 1 means, and I'm actually going to type that because it's so important. this is the 25th percentile. Now, a percentile is how much of the data is at this point or lower. The median here, so if I go back to the median is my second quartile. And the second quartile is the 50th percentile. So the median equals the 50th percentile. And what that is saying is 50% of my data is at this point or came before. So it's really different than saying, what's your grade? You might say, I got an 84 on the test, but that 84 would fall within the 50th percentile because half the kids in the class got an 84.5 or less. So saying a percent, which is your actual grade, versus a percentile, which is where you are located in the data. Very important. You know what? Let's just write that down. A percentile is where your data point is located in the data list. So it's a location, very different than the word percent. And now the upper quartile, so this is my third quartile right here, which, let's go back. All right, so this here is my third quartile. Oh, come on, stupid thing. So my third quartile, which is also called the upper quartile, or is called the 75th percentile. So we have different names. So this upper quartile, or the 75th percentile, this would be that if you got a 93 on the test, okay, your grade was 93%, but you fell in the 75th percentile of the data. So very important that we take our time and we study what these words are. Mode is the number that appears the most. And in this case, there is no one number that appears the most. 72, 84, 88, and 100 all appeared twice, which is still more than the data that appeared once. Now, why do we need these things? Well, our sample standard deviation is going to come from our interquartile range. And the interquartile range, there's a mouthful. The interquartile range of the data is going to come from quartile 1 to quartile 3. The interquartile range is from 75 to 93. So if we were to look at this, if you have a maximum of 56 and a minimum of 100, you have a range of 44. But this range of 44 is different than the interquartile range, which is 18. So if I were going to take a look at this, I would make a number line, and my number line has to be in order, and it has to be counted in equal increments. You have to scale correctly. So if I have my lowest at 56, I might start at 55 because I'm going to 100, and then it's easier to count by fives. But here's my 56. If I put a dot above my 56 for my minimum and a dot above my maximum, these are what's called the whiskers of a box and whisker plot. These are showing the range of my data. Now, the box comes from my quartiles. My lower quartile, my first quartile was 75, and my upper quartile, my 75th percentile, was at 93. So now I'm between 90 and 95. My median is a thicker bar, my 84.5, and then I build the box, and then here are the whiskers. You might remember this. My sample standard deviation would be coming from in here. Most of my data should be clustered in the interquartile range if I have good data. And this would actually be the clustering of most of the data on a normal curve. So in theory, we should have 50% of our data inside the interquartile range, because 25 to 75 is 50%. Now, is this true of this data? If it is, then I have really good data. So if I go up here and I say, okay, I have to go from 75 to 93, let's count what we have from 75 to 93. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 pieces of my data. Well, 10 out of 18 is actually a little more than 50%. It's actually 56%. So you know what? Since more than half of my data, half or more, is clustered in this interquartile range, this is really good data. So that's a good question that we can ask. Now, what is the population standard deviation of this data? Well, that's when we go back to our calculator, and we have to go back up here so we can see my population standard deviation to the nearest tenth was 11.2. And so here are the directions again in case you needed it. So my population standard deviation was 11.2. And I'm just going to write that as best as I can down here. Now, this is why we need this. When we want to figure out our spread of data, when we want to start analyzing it, this is what we would do. Now, here it says, what percent of the scores were within one standard deviation of the mean? Well, that's what I did right here. Here's my mean. Here's my mean from this data up here, which was 83.72. I rounded to 83.7. And one standard deviation lower than my mean would be subtracting that 11.7, which gives me 72. And one standard deviation above my mean would be 83.7 plus 11.7, 95.4. So the spread of my data, one standard deviation from the mean, would go from 72 to 95.4. If I went to the actual data list, that would be 13 pieces of my data out of 18 fell within one standard deviation, or 72% of my data was one standard deviation of the mean. Now, it's really important that when you're given a data list, you use that data list. If you don't use that data list, you're going to be in trouble. Let's look at the second part. What's within two standard deviations of the mean? Well, again, here's my mean. And if I go two standard deviations lower, that means I am taking 83.7 and I'm subtracting 23.4 because I doubled this. Or two above means I'm adding 23.4. So now that gives me my data that falls between 60.3 and 107.1. When I go up to my data list, that's 17 out of 18 pieces of data. That's 94% of my data. When 94% of my data is falling in between two standard deviations, then I can be pretty confident that I have some pretty good data. So this is a little strange, a little bit getting used to. So let's look again. A percent is a number per 100. It's a ratio. It would be your grade on a test. Now, a percentile is the position of the data within your entire data list, like I wrote on the other page. So an 84 on the work that we just did is at 9. It's the 9th piece of data. And 84% on your test is a good grade, but it's the 9th piece of data out of 18. You're in the 50th percentile. So you have to be super, super careful of looking at the word. Are they asking you for a straight percent or a percentile? So let's say this quiz, you were one of the kids that got back a 78. Well, you got a 78. You got a C+ on your quiz. Your percentile, though, is only 33 1/3, because only 6 people got what you got or got lower. Now, if you got a 90, which is an amazing grade, 12 people in the class got what you got or lower. That only puts you at the 66 2/3, or roughly 67th percentile. So the grade is good, but compared to the class, you were you know, so that's why when your SAT scores come in the mail, they tell you what you got, but then they compare you to everybody else that took the same SAT at the same time. So you always want to look at your percentile if you want to see where do you stand in relation to your peers. Very, very important concept. All right, so now if we look at the second page of this, nope, this one is actually not on the second page. This is one that I just made up, or I took from someplace else. But let's practice this one. The heights of 15 players on the Arlington boys varsity basketball team are given below. So here you go. Now, if you stop the video and you put this into your calculator, okay, now come back and here you go. You should have this on your calculator. You should have had n equals 15, and you should have had quartile 1 was 68. The median, the second quartile was 73, and quartile 3 was 75, giving you an interquartile range of 7. So your quartile 1 happened at 68, and your quartile 3 happened at 75, and your median was right here at 73. So there's your median. Now your range was 79, and your minimum, your range went from 79 minus 66 to 13. So here's my 66. If I was going to make a box and whisker plot, and here's my 79. So notice I didn't just jump around on the number line. I was very consistent with my labeling. My first quartile is at 68. And my upper quartile is at 75. My median is at 63, which is, whoa, let's make that a nice thick bar. And then here are my whiskers. You are going to be making me a box and whisker plot. So please make sure that you're comfortable with the calculator and your quartiles. And here's the problem again. All right, let's take a look at exercise 2. Now, exercise 2 also gives you a data list, but it's got 2 lists on it. Now, this is pretty important. Let's go to the calculator and let's enter this in. We have to second memory 4. Now, you must have list 1 and list 2. The calculator is programmed. Your first list is always X, and then your second list is Y, or it's the frequency. Now, list 1, if we type in list 1, we have 25,000, and then 32,000, and then 45,000, 58,000, 75,000, and 120,000. So these are salaries. Now, if you cursor over, now we're on list 2. 5 people are making 25,000. 21 people are making 32,000. 14 people are making 45,000. 7 are making 58,000. 2 are making 75,000, and only 1 is making 100,000. And again, always double check that everything was typed in correctly. Now, when we want to get the stats on this, we have to hit Stat, Calculate. We're still using number 1 variable statistics. Now, on a newer calculator, you would have on your screen L1, and then by frequency, it would say L2. Now, my calculator is an old calculator, so the only way I can get L1 for the first and L2 for the second is I actually have to type second L1 and a comma, and then second list 2. But you have to physically put in L2 by using the second and the 2, and then you have to go to calculate and you have to hit enter. And here we go. The data added up to 42,060. Now, here's the thing. This adds up to 50 people. Well, that goes with what the problem said. The problem said that we have a company with 50 employees. But we have to attach the frequency to the salary. So 5 people made 25,000, that's 125,000. Then 21 people made 32,000. I can't multiply that one in my head. But when you add up all these salaries, that adds up to 2,103,000. Divide that by 50, the mean is $42,060. So the average salary of this company is $42,060. Now let's go back to this and let's find the standard deviation. Now they didn't say the sample, they said just the plain old standard deviation. Now the standard deviation, they didn't say how to round, so since this is dollars and cents, I rounded this to $16,567.93, just because it's money, money gets rounded. What is the mean of this set of data? Median rather. And why is the median considerably lower than the mean? Well, let's take a look at our calculator. If we go down the line, there's my median, 32,000. Now my average was 42,000. So why do you think that it was lower? Hopefully you thought about it because more people are making less money. The average used these top salaries. Now this would probably be the owner and the 2 supervisors. You know, the 2 vice presidents, the president, the 2 vice presidents. Then maybe these are some supervisors and, you know, the floor manager and then the people, you know, that do all the grunt work. That's probably the way it works. And that's why. Does more or less than 50% of the data fall within one standard deviation of the mean? Now, guys, when they give you the data list, you have to use the data list. We are going to see theory with standard deviation as we move through this unit. This is the beginning. And when we get to the test where we mix the beginning and the end together, if they give you a data list, you have to use the data list. And so from this data list, if I am one standard deviation from the mean, here's my mean. And I rounded my standard deviation to $68 just to make it easy. One below, $42,060 minus $16,568, and $42,060 plus $16,568. Here's my spread. One standard deviation within the mean went from 25,492 to 58,628. How many people is that on the list? Well, let's look. 25,492, I can't start here. I was 400. This is 0. So that means I would be starting here, and I'm ending at 58,628, means I am ending at 58,000, because there is no amount in between. It jumps up to 75,000. So when I add up 21, 14, and 7, I get 42 out of 50. 84% of my data is falling within one standard deviation of the mean. So exercise 4. A questionnaire went home to all juniors concerning their ability to bring and use mobile devices at school. So this is like from 2015, so it's a little different than it would be today. Questionnaires constituted a census of all juniors. Of the 742 juniors, 564 of them reported having a web-enabled mobile device. And, now everybody has the web on their phone, but, back in 2015, not everybody. So they want to know what was the population proportion, which is another word for percent, of this population of 742 juniors, what percent of them have the web on their phone? And then that would be, so that's important to make note that we can ask you the word percent as a population proportion. That would be 76%. So you should definitely underline that. A proportion of eggs that get cracked at a local egg handling facility is 0.023. If 2,500 dozen eggs are packed in a factory per day, what should we expect to be the number of eggs cracked? Well, they gave us 2,500 dozen, but if you recall, a dozen has 12 eggs in it. So we're talking about 30,000 eggs. And if 2.3% are broken, we should expect 690 eggs are cracked, and that would be choice 4. So today I want you to finish this packet. It ties in everything that we talked about yesterday as well as today. Take your time, do your best, and as always, let me know if there is any question I can help you with.